After aligning the vertical height, the first time you touch the knurling wheel to the surface and feed it in just slightly, and then the intent is to get the lines parallel to the axis, and that only about 1/3 of the wheel is making contact with the work, and this gives it enough back clearance while cutting. We are now set up to start knurling. There's a chamfer on the end. 1 millimeter in from the chamfer is where we've got the tip of the knurling wheel, and we've zeroed the DRO, and so at 1200 RPM, which is roughly 300 and odd surface feet per minute on 3/4 inch aluminum, we're doing 1200 RPM. As soon as the spindle gets up to speed, we'll wind in to 1 millimeter on the diameter, which is the same pitch as the knurling wheel, and then we start feeding at 0.003 of an inch per revolution. And I'm doing this dry because the air blast and coolant is making more noise than I can talk over. So here we go. And there we have a knurl. A little bit noisier than usual. The lubrication usually quiets the thing down quite a bit, but there's the knurl. So this is the resulting knurl, and I didn't get the axial alignment quite right, so there's a slight angle, but it's a well-formed knurl, and basically no increase in diameter, and a nice clean transition to the original diameter. And that's just a view of the cuttings that come off. They're nicely formed little chips. That's the knurling wheel. As you can see, there's a bunch of swarf on it. Normally with air blast and a bit of coolant, the chips get blown away and they don't get regurgitated and mess up your knurl. And so you end up with very smooth knurls as a result. Okay, I've set things up again. I've dialed the surface feet per minute down to about 80, so almost 1000 RPM. Once again, I'll wind in 1 millimeter along the x-axis to start the knurl, and then I will feed at 0.08 millimeters or 3 thou per revolution. And this should not be quite as noisy, and I think for this type of lathe it's probably more than adequate. Here we go. And again, because I wasn't using air blast and coolant, the chips reground a little bit. I'll show the end result, but again, it's a very clean knurl, and went to a bit of a groove, so it's protruding a little bit. But normally the surface diameter doesn't actually increase. So this is the knurl cleaned up a little bit with a brass brush, but as you can see, some of the surface damage from getting the chips reground as it was cutting. And it's not quite as bad as when you're form knurling, but it's still not quite as attractive. Once again, using air blast and coolant gets the chips out of the way, and you end up with smooth minerals, as I've shown in some of the other photographs in this sequence.